All right, so let's take a look at the retro quiz. The retro quiz deals with some of the most important concepts of coordinate algebra. So let's take a look at the first problem. There is a pond full of 75 frogs. Each week, 5 frogs jump away and never return. All right, so let's start with week 0. Week 0 is the number of frogs at the beginning. So that's going to be 75. If each week 5 frogs jump away, we know that's just going to be subtracting 5. So 75 minus 5 is 70. Okay, second week, 5 more jump away, so that's going to be 65. And this pattern is going to continue. Well, let's say that I wanted to know after the 20th week. We wouldn't want to keep making our table all the way out to the 20th, and we don't even know if that would make sense. So let's take a look and see if we can find a pattern. So our first one starts at 75. All right, so I'm going to rewrite 70 as 75 minus 5. All right, no big deal. Now, I'm going to rewrite 65 as 75 minus 5 times 2. Now, the reason why I'm going to write it like that is because we know that we subtracted 5 2 different times. All right, so now 60 is going to be 75 minus, well, we subtracted 5 3 times. And remember, multiplication is just repeated addition. So you can see if we continue down this pattern, we're beginning to see a structure that it's always going to be 75 minus 5 times the number of weeks. So what we can do up here for write an equation to model this situation is y equals 75 minus 5 times x. Now sometimes we like to see the x term first before the constant, so I'm going to also rewrite that as a negative 5x plus 75. Notice my 75 is positive in both equations, and my 5 is negative because it's losing. Now, if I wanted to generalize that, okay, so let's generalize this. We're pretty used to it, but let's go ahead and take the time to do it anyway. That's going to be y equals mx plus b. We know that it's going to be linear because we're subtracting or adding the same thing over and over. So m, or in this case negative 5, was our slope. That's what we're moving every time. It's going to be our constant rate of change. And then b was our 75, or that was our starting point. We call our starting point the y-intercept. So again, this was linear because we were adding or subtracting the same thing every time. All right, so now let's take a look at part B. Part B said use the equation to find out when the pond will have 40 frogs. Well, 40 frogs is going to be our y value. So what I'm going to do is I'm going to take my equation, y equals negative 5x plus 75, and I'm going to substitute in 40 for y, and I'm going to work backwards. Now, I know a lot of you don't like to show your work, but I think it's good to write your equation out so that if you do make a careless mistake, I can still see that you knew how to plug this in. So we're going to subtract 75 from both sides of the equation because we're trying to find for x, or the number of weeks. 40 minus 75 is going to give us negative 35, and that's going to be equal to negative 5x. So our last step is we're going to divide both sides of the equation by negative 5. And when we do that, we're going to get x equals 7 weeks. Okay, now there would be other ways you could use this equation or find this solution, but again, it said to use your equation. So this is a linear model because we're adding or subtracting the same number every time. That number that we're adding or subtracting is going to be your m, and your b is going to be your y-intercept. All right, we're going to skip over this grandmother gave you a new car for a minute, and we're going to go ahead and go to the number of bunnies. All right, so the number of bunnies at a petting zoo begins with 6. So at 0 months, we have 6 bunnies. Each month, the number of bunnies triples. Well, what does triple mean? It means we're going to be multiplying by 3. Automatically, I know that it's going to be exponential because when you're multiplying or dividing by the same number every time, we have learned that that's going to be an exponential model. But let's go ahead and build it in our table so that we can see where the formula comes from. So we're going to do 6 times 3 to get to 18. 18 times 3 to give me 54. And let's see, 54 times 3 is going to give us 112, I believe. All right, and so on and so forth. All right, so let's see that if we can structure this again differently. I'm sorry, that is 162. Let's correct that. Sorry. Let's see if we can structure this. So we got 18 by taking 6 times 3. Well, how did we get 54? We multiplied 18 times 3, but remember 18 times 3 was just 6 times 3. So we could write this as 16 times 3 times 3, or 3 squared. We could write 162 as 6 times 3 to the third power, because each time we're multiplying by another exponent. All right, so we already know that 4, without knowing the answer, would be 6 times 3 to the fourth. Now, if you notice, the exponent in every case comes from this x column. All right, so let's see if we can write our equation up here. So an equation to model the situation is going to be y equals, we always have our 6, times 3, which is our multiplier, to the x, or to the number of weeks. Now let's see if we can generalize this. All right, so I need a little more room. I'm going to come down here. So y is equal to a times b to the x. Now in this case, our b is actually not our y-intercept. Our b is going to be our multiplier, or our base. Our a in this case is actually going to be our starting point, or our y-intercept. Now, one important note about the base. If you happen to be dividing, then that base is going to be a fraction. So let's say you were dividing by one half. I'm sorry, if you were dividing by 2, then your base would be 1/2. All right, so now let's use this equation to find out how many bunnies there are after 1 year. Now be careful here. Our unit in the time here is 1 year, although here it was the number of months. So we actually want to take our equation and we want to fill in 12 for x. So y equals 6 times 3 to the 12th. Simply plug that into your calculator and we get 3,188,646 bunnies. That is an awful lot of bunnies. Now, you didn't need the equation, or you could have just continued in the table, but that would be a pain. So again, an exponential equation is going to be y equals a times b to the x, where b is your base or your multiplier, and a is your y-intercept. All right, let's see if we can go back and do this last equation. So instead of building it in the table, because it's a little more complicated, I'm going to give you the equation, and then you're going to verify. All right, so our equation is going to be a, and you can use y if you want, equals a sub 0 times 1 plus or minus, and what that means is sometimes it's going to be plus, sometimes it's going to be minus, r to the t. We use this when it's exponential by a percent. All right, so let's fill it in. It's going to be a equals, a sub 0 is going to be our y-intercept. So that's going to be 23,000. Now the 1 is always there, and again, if you want to know more about that, come see me. And depreciates means we're going to be subtracting, so it's going to be minus. And then r, you always have to change a percent to a decimal. So it's going to be 0.052 to the t. All right, now you can use this formula and plug in these different values of x or t to get your answer. And then to get your final answer, just plug in 7, and there you go.